Hello, my name is Greg. I'm a hobbyist CNC user who has a home-built CNC Plasma Table, and I use Vectric software to produce toolpaths for that CNC table. And this video is about how I go about producing toolpaths suitable for the CNC table with Vectric software, which, to be fair, is not specifically designed for plasma toolpaths. It's more of a router type software. Excellent as it is not specifically designed for doing plasma toolpaths. Okay, so now why would I use it then for plasma toolpaths? Well, it's pretty simple. I already own it. I've been using it for over 10 years. I'm very comfortable with it. I like it. I love how it is CAD CAM combined, and I like how it is very intuitive to use. Now, if I was, or you were, to build a CNC plasma table or buy one and have do not already have CAM software and you're looking for it, there are specialist CAM packages for plasma use which you might want to look at. But for me, this is the way to go. Okay, so what we're going to do is very quickly, first of all, this is not going to be how to use Vectric software, how to draw, how to trace, how to do all those sorts of things. Vectric itself has many very comprehensive video tutorials on how to use their software. There's no need for me to double up on that sort of stuff. It is also not a tutorial on how to use a CNC plasma table. It is simply about how I produce toolpaths suitable for the table using this software. Okay, now what I'm using here is Cut2D, which is the base or entry-level software for Vectric. They also have VCarve Pro and Aspire, but plasma toolpaths are quite simple 2D toolpaths, and any of those softwares will do exactly the same job as far as that is concerned. Okay, now I'm going to run through very quickly a couple of just examples of typical things that I might do. Here's the first one. This is quite a simple shape. I traced a photograph of a sambar deer for a friend who is a deer hunter who would like a weather vane with this as the ornament on top of the weather vane. It is a very simple shape. It has no internal cuts, just external cuts. So we'll just quickly go through this one. I'm going to choose a profile toolpath and quickly running down. I have a cut depth of 1mm, which is kind of irrelevant, but then I select a tool. Now I have already made up here a range of tools for different thicknesses of material that I would typically cut. In this case, I'm going to choose 1.2mm. Now, just briefly, how do we arrive at these tools in the tool database? Well, Vectric has no specific tool for the tool database for plasma. So what I do is I start with an end mill. I make the diameter of the end mill the width of the kerf of the cut. Pass depth, I just make 1mm. Step over is irrelevant. Spindle speed is irrelevant, although if you put 0 it will reject it. And the feed rate is, for me, I get good results at 4,600mm per minute. Plunge rate is also irrelevant. You'll notice I have quite a few different thicknesses of material here. They're pretty much the same except for the feed rate. So that's what I do. So I'm going to select that tool. This is an outside cut, cutting in a climb direction, which is what you do with a plasma. Moving on down, what I need to do is I need to add a lead. Now when plasma pierces the material, it leaves a hole that is generally larger in diameter than the width of the kerf. So you don't want to start without a lead, or you'll end up with a divot in the job. So I add a lead, in this case circular lead, radius of 4mm, lead length of 5mm. A lot of people will use a lead out. I generally don't. I find I don't need it, but I do generally have an overcut. Now I just set that at 1mm. Okay, so I'll move down here. I'll call this deer and calculate that. And here we have our toolpath. Now you will see it's going around the outside, allowing for the width of the kerf. Here's the lead in, starts here, leads in, goes around, comes around, overlaps 1mm. Bit hard to see, but that's what it's doing. Quite a simple toolpath. Okay, so I'm going to save that out. Now here I have my post processor. We'll go into this later on and talk more about this, because this is how we arrive at these toolpaths, suitable toolpaths. But I'm choosing that post processor, saving the toolpath, calling it deer, and saving it out. Now then I go to my control software for my CNC Plasma Table. This is UC CNC, which is what I use nowadays. I used Mach 3 for a long time, but I now use UC CNC. This screen set, or what you see here, is something that I have modified for my own purposes. So it looks a little bit different to the standard screen set, but that's neither here nor there. So I can load that file, and here we are. And okay, so we'll go to the machine. We won't talk about this just yet. We'll go to the machine and cut this quickly, and then come back and do another example. Here we are back in Cut2D with another example. Here we have another decorative item. This is a representation of a self-crested cockatoo, which is a very common, prolific bird in our area. Again, this is a ornament or decoration that gets welded, placed on the top of a weather vane. And it's just a little bit different in that it has some inside cutouts, but also importantly those cutouts are quite small, and we need to give some consideration to lead-ins. So just very quickly we'll run through this again. We'll select profile toolpath. We've got the same tool, same depth of cut, same outside cut, all those things are the same. We come down to leads, and this time we're going to add a straight lead of only 1.5mm long. And we'll call this one Cocky, and calculate. Now we come up with this warning. To avoid gouging, one or more leads had to be reduced in length or removed completely. Check the toolpath is still suitable for your requirements. Okay, now when we go and look up to some of these small things, we see that this lead is okay. The eye is fine. We look at this one, it's going to be okay. That one's fine, and this one will be okay. But that's why we made those lead-ins as we did. So we'll close that one, we'll close that. Now just for the purposes of keeping this as short as possible, I have another example here. I'm going to turn off Cocky and turn on another example which will fit on the same piece of material. This is a very common type shape, just a flange. What are they, 5 bolt holes? I think these are approximately 1/2 inch in diameter, and we'll make a toolpath for that. Again, everything is pretty much the same. It's going to be cut from the same material. Come down here to leads, we'll return to our circular leads, and we'll go a radius of 5 and a length of 5, no lead out, overcut distance. We'll call this one circle, and we shall calculate. Now, when we come up here and have a look, we see that our lead out is not really suitable on these small holes. So what I'm going to do is I'm going to just reduce that radius down quite a bit and recalculate, and we can see we've moved the lead in, pierce and lead in away from the outside of the hole, and that looks like it will be perfectly okay. Okay, so I'm going to save those 2 toolpaths using Plasma Post Processor. We'll call this one circle. I can see it's already there. Okay, we'll come to Cocky and we'll save that one as well. It seems to be there too. And if we move over to our control software, we can load up Cocky. All looks good. Or we can also load up the circle toolpath. That all looks pretty good. Vectric software, as I guess most do, knows what's an inside cut and what is an outside cut. It will cut all these inside holes first before cutting the outside, which is just makes sense in almost every case, whether it's a router or a plasma cutter. So let's quickly go out to the machine. We'll cut these and come back and talk about how and why we arrived at this toolpath and the features that make it suitable for plasma cutter. Okay, here we go. Alright, here we are back in Cut2D, and now I'm going to talk about how we actually arrive at G-code that is suitable for the table using Cut2D or Vectric software. Now I've created here it's just a line going from the origin to there, doesn't matter what it is, just a line. I've created a toolpath to cut along that line, starting here, which happens to be the origin, ending here. Simplest, shortest piece of G-code that I can devise. and I've saved that out, and here it is in a text editor. Okay, pretty simple. Here we are. First move the torch to the beginning of the cut, which happens in this case to be the X and Y origin. Then we move on to this section. Now what does this all mean? M12 is a macro that does what we call a touch off. It probes the surface of the material with the tip of the torch to establish the torch or z-axis 0 or origin at the surface of material. Then it retracts the torch to the pierce height, or whatever height is appropriate to pierce the material that we're cutting. M3, just a standard command, means start the spindle in a clockwise direction, or in this case turn the torch on, or squeeze the trigger if you like, start the arc. Then we move on to M13, another little macro which simply delays everything for the period of the pierce, or what we call the pierce delay. Then we move the torch to 1.6 above the material, which is about a 1/16 of an inch, and that is the correct height for cutting. That's the desired height. Then we carry out the cut, or the movement of the cut. Now in this case, just one simple line of code. This might be 100 or even 1,000 lines of code to go around the shape of the deer, or whatever it happened to be, doesn't matter. That's the movement while we're cutting. Then at the end of the cut we come to this section. M5 simply says stop the spindle, or in this case turn off the torch, stop the arc. Then we move the tip of the torch to 10 millimeters above the plate, which is just the height that I desire to then move on to the next cut. Now if we had a next cut, we'd have this section again, then we'd have movement again, then we'd have end, and they might be laid out one after the other. Doesn't matter. Here we've only got one cut. And then end of the code. I just move the torch up to what I find is an appropriate height at the end of the cut, move the torch back to the origin of X and Y. M30 just ends the code and rewinds it. Okay, now why do I use these couple of macros here? A lot of people will use straight G-code. You can do that, perfectly legitimate. The reason that I choose to do this is, well, I find it simpler, but when I go into my controller, here's the code, M12. M12 picks up the value that's in here. I can set whatever my pierce height I like to be appropriate for the material that I'm cutting, and M12 after touch off will raise to that height in preparation for pierce. Over here I have pierce delay in seconds. M13 simply picks up that value. I can take whatever value I want in there that's appropriate for the material, and M13 will delay for that period. So that's why I use these little macros rather than straight G-code. It just suits me better. Okay, going back to the code. Now how do we get the Vectric software to establish or make the code in this way? That's done with a post processor. Here is my post processor for my table. Now I would stress, don't be afraid of this. The post processors in Vectric software are one of its many great features. They're very simple to work with. They have an excellent guide provided with the software that explains every line and what it does, and it's really very simple. Now when I want to make myself a new post processor, I just grab an old one, make a copy of it, retain the old one, and then start hacking, adding, doing whatever I want to make the post processor what I need. Now, unlike Vectric official post processors, which need to cover all sorts of users' wants and needs. I only need it to do what I want, so I tend to cut a lot of stuff out. I keep everything very simple. Okay, don't worry about that. It doesn't matter. You don't need to cut all that stuff out. That's just my personal preference. What's important here is, here's the name. This is what appears in Cut2D or whatever when you choose your post processor while calculating a toolpath or saving a toolpath out. Text is just the extension that I use. This is millimeters. A lot of people will be inches. Okay, pretty simple stuff. As you can see, I cut a lot of stuff out. I don't like line numbers. I like my code to be as simple and easy to read as possible. I leave spaces between code. All those things don't matter. That's just my personal preference. What I do need to do is take out every reference to the Z-axis or Z-axis. So I remove any reference in all of these standard moves to the Z-axis. Just take them out. And then we get to the important part, which is the command called plunge move, or begin plunge move. Now you'll notice here, this is exactly that. All it does is place this at the beginning of a plunge move. And that's how it does it. So that's why we use plunge move. Then we move to retract move. And you'll notice it just places this there at the end of the cut and does exactly what I explained it to do. And here's just my footer. Again, it's pretty simple stuff. Nothing to be afraid of in here. And it will create the code that I need to run my plasma table. Now, I know some of you will be saying, oh, well, what about some of the specialised things that something like Sheet Cam will do, where it'll turn on and off the torch height control at appropriate times and things like that? I simply don't need that. My controller software takes care of that. Mach 3 takes care of that. CNC can take care of that. I'm sure lots of other controllers can take care of that. This does everything that I want, and that's why I use it. Okay, so I hope this has been helpful to someone, and thanks for watching.